Okay, so here's problem number 7 out of the book. Again, same directions as the problem number 5. Find the inflection points, and then find the excuse me, find the concavity around those inflection points. So I'm gonna have to do the second derivative to get through that. So f prime of x is 4/3 x to the 1/3 plus 4/3 x to the negative 2/3. And the second derivative is f double prime of x equals 4/9 x to the negative 2/3 plus negative 8/9 x to the negative 5/3. Now there are two ways you can approach this to find the second derivative for the solving part, because that's really that's like 90% of the issue for this one is the solving. Either way, you're going to set it equal to 0. One thing you can do is you can take out, and I know it might seem strange to do this, but you can take out a 4/9 and you can take out an x to the negative 5/3. Now if you do that, what that means is you're subtracting negative 5/3. So if you have negative 2/3 minus negative 5/3, whoops, let me get my fraction over here. That's really like adding 5/3, which is 3/3, which is 1. So this becomes x to the first power. I know it's strange, but if I redistributed it, it'd be 3/3 plus negative 5/3, which is negative 2/3. And then negative 4/9, take out 4/9 from negative 8/9, that gives you negative 2. And that's probably the easiest way to solve it if you're comfortable taking out fractional negative exponents. If not, I'll show you another method in a moment. Now, I do have an issue here where x could equal 0. The problem with that is that would give us an undefined here, and we don't want undefined for inflection points. We actually just want zeros. But just to talk about it, we'll look around 0 anyway. So our inflection points are not 0. I'm going to put 0 in quotes just to talk about that undefined portion. And then 2. Okay. So if I do my little number line business, I've got 0, I've got 2, and again I'm putting 0 in quotes. So what I have to do is I have to evaluate for a number bigger than 2, or actually less than 0. So go back to my graphing calculator. It's easiest just to go back up in here, plug this in. I've got x to the 4/3 plus 4x to the 1/3. And again, if you'll notice, I've been doing for all these problems, I've kept the second derivative and the first derivative and the second derivative in y2 and y3, and that's going to allow me to say, okay, let's do y3, which is the second derivative, because I'm doing the second derivative test, of let's say something less than 0, so like negative 1. I get positive. Okay. Now we try something between 0 and 1, or 0 and 2, excuse me. Second entry. No. Second entry. Positive 1 now is in there. It's negative. And then second entry, something after 2, like let's say 3. It's positive. So let's take a look then at our graph. Zoom 6. So we really should have counted 0, even though it gave us undefined here, because what we actually have is a vertical tangent, because 0 came as one of our solutions at the beginning. So So we do have this change in concavity here, even though this is undefined for that value, and this is 0. So as you can see again, it's concave up beforehand. And then it's hard to tell, but it does switch in the middle here at 2. So again, I guess strike my previous comment there. We should have looked at 0 for undefined values. So now, as far as our concavity is concerned, we are concave up from negative infinity to 0, and then from 2 to positive infinity, because this is an open interval forever. We're concave down between 0 and 2. And then we'll go back and find our inflection points. Okay. One's at 0, so 0, 0. And then the other one is 2. So I got to do y1 of 2. And I can do it here on the calculator real quick. I actually do second value 2. Which doesn't give us a great value. I can go to the table as well. y1 of 2 is 7.5595. If we want to do exact values, we could do, I guess, be like 2 to the 4/3 plus 4 times 2 to the 1/3. Gosh, trying to simplify that a little bit. Well, let's get fancy with the simplification here. So we have 2 to the 4/3 plus 4 times 2 to the 1/3. That's really 2 times 2 times 2 to the 1/3. Which this is 2 to the 3/3 then. So we have plus 2 times 2 to the 4/3. This actually ends up being 3 times 2 to the 4/3. But again, that's just, hey, great, look, there's a weird, irrational number for a solution. Decimal will work okay for us well enough. Okay, so there we go.